Hello again. We are here at the last stop on our Monday tour of Northeast Ohio, which is part of the week-long Green Energy Ohio electric vehicle tour. And our last stop is really going to be one of the most interesting because we are at SARTA in Akron, where they have a fleet of fuel cell powered electric buses. Something very unique and something we are going to hear a lot more about, and we're going to get a ride. And I'd like to introduce Mark Finicum. He is with SARTA, and he's going to start telling us about this technology and how they use it.
Thank you, and welcome to SARTA. SARTA currently operates 12 40-foot hydrogen buses, which you can see here in the background. We have five of the paratransit vehicles as well, for a total of 17. Our 18th will be coming in later this year. The difference between this and a standard vehicle, as you know, by opening up the rear hatch, there are no moving parts here in the engine bay. What you have is a fuel cell right down here at the bottom that takes hydrogen off the roof of the vehicle, generates electricity, which powers the drive motor and the auxiliary power and the compulsion units here. So typically, instead of recharging these vehicles by plugging them in like you would an electric bus, we use hydrogen, liquid hydrogen, hook it up just like you would a standard gasoline vehicle or anything else. It'll fill in about 20 minutes. It'll have 50 kilograms of useful hydrogen on the top that runs down through an 85 kilowatt fuel cell that generates the electricity that powers this vehicle. So basically, this is a battery bus. There is lithium-ion batteries on the roof, 28 of them, that are powered, instead of being plugged in at night into 120 or 240, we power them through hydrogen. The hydrogen we use is trucked in from Sarnia, Canada, Sarnia, Ontario, Canada. And I'll take you around here in a minute and show you that station. This vehicle right here is a paratransit vehicle that we are doing a prototype study on. It has 13 kilograms of hydrogen, usable hydrogen in it. It has a range of 250 miles, so it is, again, an electric vehicle. Instead of being plugged in, we draw all the power from hydrogen and extend that battery's life to get the 250 miles per day out of that vehicle. So, any questions or anything on the fueling? This is manufactured, the El Dorado is manufactured in Riverside, California. The paratransit vehicle is made in LA by US Hybrid, and they are both part of our 18 vehicle fleet at this time. So if you want to walk around, I'll talk about the station. This station that you're looking at right now is an Air Products station. It was built in 2016. It has a 9,000 gallon storage tank, which has cryogenically frozen liquid hydrogen in it. So it's at a negative 420 degrees. That tank is probably about 2 inches thick. So it's like a giant thermos bottle. The hydrogen is taken from the tank where it's compressed up to the 350 bar of 5,000 PSI at the two pump stations. So we have redundancy. If one pump goes down, we have redundancy with the second pump, so we're never out of business. It's then taken through the heat exchanger and stored in a cascade tank system. So from those tanks, then we draw on it nightly and directly from the pumps to fuel the vehicles each night. On average, they use about 30 kilograms a day. The buses get about 200 miles per day on the 50 kilogram tanks. We have 60 kilogram that'll get about 250 miles a day. When they come back in, the buses are designed not to run out of fuel, but they'll come in, the system will sense how much they need, and then allow it to be fueled from either the storage tanks or direct off the pumps. We usually get one shipment a week from Air Products. As I said before, it's shipped in from Sarnia, Ontario. All in, we're at about, with transportation costs, about $6 per kilogram. Where out on the West Coast, you're looking at $13 to $18 a kilogram. It's almost doubled, a little more than doubled. We have looked at and talked about doing on-site production, which may still be something down the road, but currently everything we do is shipped from Air Products to us and maintained by Air Products as well. Okay, this trailer is Nice Energy. It's corporation that is testing a theory on the hydrogen production and a new way to do it. What you're looking at on this semi-trailer is everything that you saw out front minus the 9,000 gallon tank. The tank that's on here is 1,500 gallons. Instead of having two redundant pumps that will compress the hydrogen, they actually have piston-driven pumps inside that tank that are cooled by the hydrogen that is negative 420 degrees to allow it to have a cool, true fill. You can actually fill a large bus or a paratransit bus off this station, and it will detect which one it is by a test shot coming out of their system and allow it to fuel it at a similar rate, 10 minutes for the small vehicle, maybe 20 minutes for the large. But when they're done, you get a truer fill from this station than you do the station out front, because the station out front runs through heat exchangers. It's compressed, so the hydrogen is at a very warm state. It has to cool down. As it cools down, it also loses some of the pressure in the tanks. This station will fill at a negative 40 degrees Celsius, which when it's done minimizes the degradation of the fill. So you're actually getting a truer fill from a station that has no refrigeration on it whatsoever. Everything is refrigerated by the negative 420 degree hydrogen in that tank. So you get a true fill. This station will be conducting a test next week to break a world record for consecutive fills. They're going to do 40 back-to-back fills, which has not been done. I think the record was in the low 30s. We'll have a hydrogen tanker sitting hooked up to this, and that'll fill it throughout the day, and we will do 40 complete back-to-back fills in a 12-hour period next week. So that'll be hitting the press as well. This station, again, is Nice America's Research. It's owned by a company out of China. It's over here. This is the first time it's been used to fuel buses in the United States. After it's done here, it'll continue other testing, but this is available for the market if you do not have a footprint large enough for the station we have out front.